Okay, for number 5 it says consider all integers a such that both zeros of the following quadratic equation are integers. What is the sum of all integers a? This is the toughest question in this particular problem set. All right, so I'm going to the whiteboard, and it's time to start thinking. Again, we're doing number 5 now. This is number 5, and I got to write down what they said. They said a is an integer. I'll write this over here. A is some integer. I don't know what it is, by the way, but they say it's an integer. And then they have zeros of a polynomial. I'll write that down for you. The zeros of this polynomial, I'm going to use quadratic formula. And what are you going to get? You're going to get x equals, let's see, twice, this is the bottom number, twice the coefficient of the square term, which is 2. The opposite of the coefficient on the linear terms, that'll be a. That's the opposite of minus a. Plus or minus, here comes the tough part, it's radicand. It's going to be the coefficient on the linear term, which is minus x squared. So I'll just put down a squared minus 4 times a. I'm sorry, the a is the coefficient of the square term. I shouldn't have said that. So it's going to be 4 times that constant term. So it's going to be 8a. I could write that down. This is the part where, I can understand a lot of students get stuck now. What do I know, though? I'll read that back to you. Consider all integers a. They have to be integers. A is an integer. It says both zeros of the following quadratic equation are integers. So what do I know? I know that a squared minus 8a has to be an integer, because a is an integer. But furthermore, I know the square root of it has got to be an integer. And why is that? This thing is, the x got to be an integer in the problem. So this means this a squared minus 8a has to be a perfect square. All right? So I know that a squared minus 8a must be a perfect square. Well, I'm going to introduce another unknown in the problem. And I'm going to say, if it's a perfect square, I'm just going to say, oh, it's some number b squared, where b is an integer. I just don't know what b is. Then the question comes is, how do you do that? Well, I'm going to try to figure out what the a is in terms of, the b's and stuff. And I'm going to do it by completing a square. So a squared minus 8a. Half of minus 8 is minus 4. Square, you get plus 16. It's going to be b squared plus 16. Let's take a look at that. And let's write this down now. So it's going to be a minus 4 squared is equal to b squared plus 16. I got to think, don't I? I want to write this down now. A minus 4 squared minus b squared is equal to 16. 16 is a more manageable number for me at this point. And I'm going to write this, the difference of perfect squares, by the way. So it's going to be a minus 4 plus b, a minus 4 minus b, and that equals 16. Right, I want to remind you that a and b are integers. So a and b are integers. And again, this is the part you see, what do I do now? I gotta determine that I could look at this over here, and there's 2 factors, by the way, and they're both integer factors. They got to be 16 when I multiply them together. So I'm going to say, the possibilities of this over here is that, this could be, I'm going to put plus or minus down. This could be 1. It could be 2, because I got to get a product to be 16, by the way. Can't be 3, by the way. That's not going to work out. It could be 4. Can't be 5. Can't be 6. Can't be 7. It could be 8, though. And then what's over here? Let's see. Is there another one? Yeah, there is. 16. And then I'd say this one over here, it's going to be plus or minus again. And what does that mean? Well, let's write that down. It could be 16 now. Now, why is that? If I'm looking at these as pairs, 1 times 16 would be 16. Minus 1 times minus 16 is still 16. So the next one's going to be, let's see, 8. And it reads about 2 times 8. You get the idea, it's pairwise matching of it. And then 4. They're integers. Makes it a little bit easier for me. And then a 2. And then a 1. All right, let me think for a moment. Does this help me at all? I think it does. And the reason I'm going to start to write these down so they're aligned with one another. So I'm going to say A minus 4 plus B could be equal to plus or minus 1, 2, 4, 8, and 16. And the other one is going to be A minus 4 plus B is equal to plus or minus 16, 8, 4, 2, and 1. Now these are two equations with two unknowns in it, but really, actually there's more than two equations. I see that there's pairwise matching with it. And what I'm going to do now is, I got to think about this now. I'm going to subtract the two equations. And to do that, the reason I'm going to subtract it, it gets rid of things on me, all right? So I'm going to take the upper one. You know what, I wrote down something incorrect over here, I just noticed it. You may wonder why I noticed it, because I subtracted things would completely disappear, and that would not be good. So A minus 4 plus B is equal to 1, 2, 4, 8, 16. A minus 4 minus B is 16. Yeah, so I'm going to subtract now. Upper minus lower. What do you get? 2B. Remember, B is an integer. Oh boy, this is going to be a tough one, isn't it? I got to do subtraction now. So it's going to be plus or minus 15. And why is that? If I did 1, minus 16, that would be 1 minus 16 minus 15. And if I did, minus 1, minus 16, I get 15. Not bad to do that, but I know plus or minus, by the way. And then 6, and then 0, and then 6, and then 15. By the way, some of these don't make sense to me. I'll tell you why. They have to be divisible by 2. So this gets thrown out, and this gets thrown out. So what do I got? I have 2B. I'll write the two different ones I'm seeing at this point. And the 2B could be, it could be 0, by the way, which means the B is 0. And 2B could be plus or minus 6. And what is that going to give me? B could be plus or minus 3. All right? So at least I'm kind of reducing it to smaller understanding of what the numbers could be. And I got to go back because I'm really concerned about the A now. And I'm wondering, like, if the B is 0, what would I be coming up with over here? And let's go back to the original problem. If the B were 0, and I'm really going to go this one over here, by the way, because it's probably the easiest one I can deal with. So if B is 0, what do you get? You get A squared minus 8A equals 0. And what do you get there? A, and then you get A minus 8 equals 0. So I'm going to say I got some possibilities now. The A could be 0, or it could be 8. All right? So 0 or 8. Let's do the other one, and let's do A squared minus 8A is equal to 3. I'm sorry, it's A squared. So B is plus 3 now, right? And let me think about that. Let me see if I did that right. Oh, it's B squared. I'm sorry. I was going to say that's really not working out nicely, is it? That's a 9 then. Sorry about that. You know what? That's plus or minus 3. So I could just say B is plus or minus 3. It's going to work out this over here. Let's see what this gives us. A squared minus 8A minus 9 equals 0. Let's factor it. You get A and A. Let's see, you get 9 and 1, right? And let's see, minus 9 plus 1. Let me see if that works out, by the way. You do get A squared. You get minus 8A. Yeah, it worked good. So what do you got? I got 2 more. I got minus 1, and I got 9. Let me just put those in order for you, by the way. By the way, I'm not saying these are the right answers. I'm just saying this is leading me in that direction over here. So I'll put down minus 1. I'll put down 0. I'll put down an 8, and I'll put down a 9. By the way, these are candidates at this point. I'm wondering, is it leading to what I want? And I always wondered, like, did I make a mistake somewhere? Let's write down this equation over here. So x squared minus ax plus 2a is equal to 0. And by the way, this is the original statement. All right, let's just consider all integers a. Well, I got my integers over there. These ones that are working out for me. And they want that both zeros of the following quadratic equation are integers. Let's take a look at this. What do you get over here? Let's just do this case where a is minus 1. Let's see what happens over here. What do you get? X squared plus x minus 2 equals 0. Well, let's write this down. You get x and x, 2 and 1, plus minus. Certainly this works out well. All right, we get two integer solutions to the problem, 1 and minus 2. All right, let's do a equals 0. That's the second one in. And what do you get there? X squared is equal to 0. Well, you get two roots to that, and they're both 0. They're both integer. That works. All right, let's do a is 8. Let's see what happens there. You get x squared minus 8x plus 16. What do you get there? Well, you get x minus 4 squared equals 0. Well, it's integers again. You get 4 and 4. That's good. Let's do the 9 now. Last one to do. A equals 9. What does that give us? X squared minus 9x plus 18 equals 0. I think I could factor that too, right? That's going to be 6 and 3, isn't it? Minus, minus. So the two integer solutions there would be 3 and 6. So we're good. So what do we have over here? We have a set of numbers. I want to go back and read the question to you. We have this set of numbers over here. And what's their question is, what's the sum of all those integers, by the way? Let's write that down. It's going to be minus 1 plus 0 plus 8 plus 9. Make sure I'm doing that right. Minus 1, 0, 8, and 9. I did. And what do you get over there? You get 16. And we're done. Thank you.